This conference will now be recorded.
Good morning, everyone, and welcome to this webinar about Codezoner and static analysis. My name is Joachim, and together with me today I have Mikael, who will show some demo of Codezoner. And if you are calling in from Denmark or Finland, you are most welcome to contact my colleagues Henrik and Marco afterwards if you have any questions. I hope everyone can hear me. Else you can send a chat message. So this webinar will be a little bit about an overview of SAST, static application security testing, and Codezoner, and then we'll discuss how how it's deployed in a workflow, and then we have a short demo of Codezoner. And this session will be recorded, and we will have about 45 minutes, including questions in the end. So if you have any question, you can just send them in the chat window. So let's get started. So today we're going to talk about Codesonar, that is a static analysis tool for discovering bugs and security issues with software. And this is developed by a company called Grammatech, and they have actually two divisions. They have one R&D division that's focused more on military projects in the States, and then they have a commercial division where they offer tools for security and vulnerability checking, and one of is Codesonar that we're going to talk about today, and the other one is Sentry. Just to make a difference between these tools, you have the Codesonar that runs on source code or binary code to discover 0 days vulnerabilities. That means flaws that you have in the code that you are developing. Typically, you put that in a DevOps environment. Then you have the software security assurance, where you can use both Codesonar and Sentry. And then you have the software supply chain security, where you use Sentry. And Sentry makes a bill of material of your binary and identify codes or vulnerabilities where you have which are known and published on different databases. So what is static application security testing? Well, basically you can validate that you can follow a set of rules like MISRA, CertC, and so on. But the main thing, I think, is that you have static verification of your code. So you can discover runtime errors, API misuse, and so on. And it's also or defects are impacting the software quality and the security. So there is a big overlap between security and normal software flaws like memory overruns and so on. And a SAST solution needs to scale to the real world programs. So if you have big programs, you should be able to scale to this, and you should have it as an assistance, not a distraction to the developer. So why do static analysis? It's because when you once you can compile the code, you can start testing the code with static analysis. So you can find it very early in the process, and you can find very difficult to find errors as well, very easily. Here is one example. It's a medical industrial manufacturer in Europe that deployed some software, and after deployment it just crashed. And then I run CodeSonar and find that there was a null pointer dereference that we hadn't discovered by the normal testing routines. So CodeSonar is a multi-language static analysis platform that you analyze C and C++ mainly, but you also have Java, C#, and other things, and also binaries in ARMS and in the platforms. So it's smoothly integrated to DevOps and CI solution, and it has a very user-friendly interface that we will see later on in the demo, and it's very customized. It's able to customize very much depending on your own need or your industry. So here are some of the customers. So mainly these customers are technically developing customers that use C and C++ as main language. So how does it work, CodeSonar? Basically, you parse your code and then you just use your own build scripts and so on. And then you run some algorithms. So this model that is built up inside CodeSonar, and then the tool will explain why you have, or why the tool has issued a warning for this issue. So basically, you take your source code or your binary code and run a lot of checkers, put that in a database in order to store it. And if you have it in a database, you can filter it, you can annotate it, and you can keep track of different buildings and see trends in the software. So basically, from the database, you will be able to do exploration of errors. You get reports, dashboards, and you also get to see the errors in the IDE, like Eclipse or Visual Code or Visual Studio. So this is a plain workflow that many of our customers use. They have probably one server where you have, or one of several servers where you have your code. You check it out either to a server build or to a developer build. And if you are using a server build, you can also deploy CodeSonar in this workflow to do deeper analysis and so on for the whole project. And you can also deploy it in a developer workflow. And most of our customers do a combination of it. So I will talk a little bit about the DevOps or DevSecOps and how to use CodeSonar in that. So basically, you introduce the static application testing, and you do reviews when you do builds and address the high priority issues. You optimize your build process and configuration, and then you integrate that into a continuous integration, continuous delivery pipeline that you put out to your developers and automatically trigger analysis when you do a merge or a pull build, depending on your system. And this way of working delivers value from the step one. So you get a very fast quality check of your code. So here is one example. There is a lot of integration and coming integration to different ecosystem of CI and CD environment. So here is one example. It's the GitLab. And what you actually do is when you push some code changes, you automatically start run an analysis on that code, and you get automatically a result from Codezoner, and you can triage the warnings inside GitLab directly. But if it's not that obvious problem, you can open up and Codezoner and do a more thorough analysis when you do that. And of course, there is built-in flaw checkers in GitLab Ultimate today, but this gives a much stronger and much deeper analysis than the checkers that is built in different tools today. Here is another example of GitHub, where you just use Codesonar as a reviewer in this workflow, like a test bot for everything, every commit you do. So when it comes to static analysis, that is a recommended technology in many standards. So in Codesonar there is a lot of presets and checkers that check both functional safety standards, but also security code standard. And you can get very nice reports out of Codesonar, what's violated or not. But I will hand over now to my colleague Michael to make a demo.
Thank you, Joachim. So here I've connected to my Codezoner hub, and the hub is a server that contains the analysis results. So I'm using my Chrome browser to connect to the hub, and on the first page I can see the different projects I've been working with. And I created a small demo project for demo purposes. It's only 12,000 lines of code, so it's quite small. It's an open source project, Node.js. I've downloaded, compiled, and analyzed. So if I want to take a closer look at the latest analysis, I just click on it. And I get up this list view from a latest analysis. And first thing I can see is that I have 82 warnings in this analysis. But I have not turned on every checker that is available. I just use the default settings. I can compare that to a previous analysis I've done. Here I have 4,000 warnings. Every checker has been turned on in this analysis. But I can also mention that when you use MISRA checkers and have not written your code according to a MISRA standard, it will generate lots of warnings. So we can have a look at the different columns here. The first column, score, goes from 0 to 100. The higher the number, the more severe Codezoner think that this warning is. And this is very useful when you want to start out. You should get some hints on what to check first. And there's also a red column to the left of it. It goes to yellow and also green later on. It's a high-level indication of a score. And ID. Every warning gets a unique ID number, but we'll follow this warning as long as it still exists. So in the next analysis, if the same problem occurs, we'll get the same ID number, and Codezoner uses a fingerprint method to determine, even if it moves in the code, that this is the same warning. And this is very useful when you want to suppress a warning, so it will stay suppressed. When we have a class, what kind of warning it is, and we got the significance. It's a high-level indication of what kind of warning it is. It's reliability, security, and redundancy, and style, I believe. Then we have file, line number, and procedure, where we can find the warning in the code. And last, we have priority, state, finding, and owner. These attributes are set to ourselves, and I'm going to come back to them in a little while. Now, this view is configurable, so I can sort them in different columns. I can move them around, hide them, show something else. But I can also create a chart. So here, I will create a chart of the different warnings in this analysis. And I can see that tainted buffer access warning is the most common one. We got 14 of these. And if I click on it, I'll get the list of the tainted buffer access warnings. And followed by 9 null-pointed references and so on. But for demo purpose, I'm going to have a closer look at this buffer overrun. There's only one warning here. But let's take a closer look at this warning. So I click on it, and I will see the warning in the code. And to start off the investigation of this warning, perhaps I don't know what a buffer overrun is. I can click on this red question mark here, and I will open up a manual. So here we'll get a short summary of a warning. Buffer overrun. So we have read or write to data after the end of an object in memory. I can see against different standards that this warning is mapped against. MISRA, AutoSAR, CWE, CertC, for example. And often it comes with small code examples. So every warning is described in the manual. But let's go back to actual warning here. This is a very small example. For this warning to occur, should the benchmark code be executed? So we have a traceback that we can follow. And Codezoner helps us by describing with events in the code what is happening. And these events are, for example, we've got control flow information here. We've got some yellow triangles here, but we can click on the arrow here. We got event 1 here. We are taking the true branch. There's the value is to false. And I can step down to the next event. Event 2, S is passed test function. And I can step keep on stepping down, and Codezoner explains how it sees what is happening. All the way down to where a buffer overrun occurs. So if you take, I can make it a little bit more readable first. Take away those events. So this code writes past the end of a buffer pointed to by new lock. New lock evaluates malloc stlen s+1 on row 2209. Now this is a very simple example, but I think it's quite good example to show. A problem is that on row 2209, the developer has managed to put the +1 outside the parentheses, and therefore we get a buffer overrun later on. But if the developer had used static analysis, he would have found this error and fixed it in 5 minutes. Now I know that this specific warning existed in several versions later on. And this text comment from a developer says it all. This doesn't have buffer overflow vulnerabilities because we always allocate enough space before appending. So it shows us that the developer is thinking correctly, he just not implemented it correctly. Easily happens. So Codesonar helps us to explain what is happening in the code. So it's quite educational. And we got this cross-reference here also that helps us. So if I put my mouse over something here, I get information about that. So new lock is a local variable. I can see the definition. I can see where I read from it and write to it. And if I put my mouse over something else, I get information about that. But perhaps I'm interested in to see on which paths this warning can occur. So if I click on warning details here, and we take explore callers, graphical. So here we got the different paths that leads to this function. And if I click on check paths, it will go through all the paths and check if this warning occurs on them. So the red marked path here is the warning detected. So it's working right now. And if I want to take a closer look at one path, I just mark that, and we can view it. And in the same way, we got our traceback we can follow in the code. So this traceback goes over several different files and functions. We start in cmdc and continues on to pgn.c. And we got the events in the code also. So the Codezoner describes important events. All the way down. So where a warning happens. Now it's not uncommon to have very large warnings. This is a very short example. But when we have large warning that traverses over different files and functions, it can be very hard to manually find them. So that is the one real strength of static analysis. And Codesonar is very good at explaining the problem for a developer. And I mentioned earlier some attributes that we are setting later. We can do that here. So we can set a priority on a warning, high, medium, low, or suppressed. If we suppress it, it will not be shown in this analysis or any later on. It still exists in the database, so we can always filter them out again. We can put a state on it, assigned, fixed, invalid, later, new. We can automatically set up, so in next analysis, all new warnings we get state new, then we can filter on just the new ones. Just have a look at the new warnings. So we could basically create a baseline here if we want to, and then work on the new warnings, so we not commit any new warnings. Then we can work on the old ones when we have time for it. Finding, is it a true positive or not? And we can also set up an owner to a warning. So a correct person fixes it. And we can also write a note. If we do a suppression, we should explain why we do a suppression, for example. And these attributes will be saved in a list here. So every time we do a change to them, it gets the history of all the changes also, and who has done it. There also a possibility to use a Jira integration. Now I'm not installed it here, but if I had, I would have a checkbox here. So if I click on this checkbox, I will automatically synchronize this with the Jira issue. Some more. Let me see. What more can we do? Here I have an example of another project from GNU-chess, the same project, but here I've done analysis from version 5.05 up to version 6.03. And I'm interested to create a chart over how the warnings have changed over time here in different analysis. So very easily I can create it. I'll see analysis and number of warnings. And I would like to have some stacks. So here I can see how we're doing in the project. So from version 5.05 up to version 6.03. We have a slight negative trend between 5.08 and 6.0. We would like to have a downward spiral. But if we would take a look at the number of lines of code, we will also see that it increases a lot between these two. And we also have possibilities to create some reports. We can get the reports in XML, HTML, PDF format. And there are some built-in reports for SANS, CWE top 25, and some different MISO reports, AutoSAR, Power of 10, CertC, and so on. So we can very easily create a report. You can watch it in HTML format. So this is a standard report. So here we get the summary of this analysis. So we get the warnings in the chart, and different warnings. Some analysis metrics also. It's very easy to create our own chart if you want to. And there's also a possibility to have a look at metrics if you're interested in that. Some customers are interested in cyclomatic complexity. So that is a value that shows us how complex the code is, and that is built upon how many paths there are through the code. The more complex the code is, the harder it is to test, so that it actually functions as it's supposed to do. So here we got some values from different files here and functions. So here we got some value of 101 score, and that is quite high. As a reference, I can mention that NASA in the US look at some cyclomatic complexity. And if you write a function that gets a value over 15, you have to rewrite your code. So 100 and more, it's quite a lot. And if you click on it, we'll jump down to its function, and we can have a quick look and see that we have some, there is for and a while is nested. So we're building a lot of paths, different paths, possible paths through the code. And this make it quite complex and hard to prove that it actually works as intended. We can have a quick look at another example. We have a leak here. So I can jump down to a warning location directly. And I can see I got 30 different important events that leads to this warning. But if you read the summary here, we can see that the RFP has gone out of scope and no longer reference the resource of interest. There are no remaining references to resource on line 504 from line 504. The resource was allocated at line 504, and the reference is lost here at line 537 in the return case. And the resource has not been freed between allocation, and we will lose the reference, and we have a memory leak. So that's a slightly larger example. And we also have a possibilities to compare different analyses with each other. So we get a list of the new ones and what has disappeared from a late state from another analysis. You can choose between two different. But there's no difference between here, and I don't want to start with 4,000. It will take a couple of minutes to compile it. So that is a quick demo of CodeSonar. And we can open for questions in the chat window if you have any. Or do you have anything to add, Joachim?
No, not at the moment. Let's see if we got any questions. So one question is, regarding the owner settings, are there integration to issue trackers such as Jira? And the question is yes. As Mikael mentioned, there is an integration to Jira. Currently, it's for Jira that is locally installed, but the next release that it will be released in December or early January, it's also supporting Jira Cloud solution. And next question here is that is this a cloud-based tool or running in a local server? This is a tool that's run in a local server mainly. So that is the wish from most of our customers, that they run it in-house. But of course, it's possible to deploy on any cloud environment. There's a lot of questions popping in now. So another question is, what is the warning ID connected to? Is it line number, code pattern, or what? And yes, it's a combination of code, line number, code or path, and so on. And they developed something they call fingerprint method. So they look at different parameters to see which I would say error or issue it is, and then gives it an ID. And this technology has proven to be very successful in detecting old and new errors, even if you modifying the code and so on. And there was a questions about the plugin to Jenkins. Yes, there is a plugin to Jenkins that you can download from a Jenkins marketplace.
Integration for Tiobe.
There was a question about do you have or are planning to have an integration to Tiobe? I'm not sure what that tool is, so we need to check that. I have not heard of any integrations, but we will find out and get back. Next question, is it possible to add coding style checkers based on our code guidelines? Yes, it's possible to develop your own checkers, both for styles and for errors. What Codezoner primarily do is that you build up a symbol tree and syntax tree and abstract syntax tree and so on, and it finds errors mainly on you run analysis on this model, so you mainly find how to say programming errors, mistakes, and so on. It does not look at if you have intended the lines correctly and so on, because that will be passed out in the code like with compiler do. Next question, do you have figures of time to process compared to size of project? I interpret that question as analysis time, and you can run Codezoner with different set of checkers. So mainly, or in most cases, developers run faster checkers on the desktop, but since they don't want to wait, and you can run longer analysis or thorough analysis on a server during nights. But the average compile code is between 3 to up to 15 times the compilation time. So if it take a half a minute to compile your code, it will take 1 minute, 1.5 minutes to analyze it with Codezoner. So, but it all depends on what checkers you put on in the analysis. We got a question about pricing, and what I can mention is it's either priced by users. That means that you pay a yearly fee for each users, or you can pay up to a certain amount of lines of code that you're analyzing. So either you can how to say, pay per user and no code limitations in line of code, or you have a line of code limitation and no user limitation. And it's starting at about 2,500 US dollar per user per year, but it's very much depending on which model you use. So it can be, for small teams, it could be very cheap, much cheaper than that. One question more is, I missed how the setup configured to analyze the target project, which target the code shall run on the files includes, excludes, and so on. Yes, we didn't show that how it works, but basically what you do is when you build your code, for instance, if you have a make script, you maybe you put make all, and then you have some make files to build your software. What you basically do is that you use the same command that you use today, but you put Codezoner analyze a command before that, and then Codezoner just look into your build script and how you build in the code, and that ensures that you just analyze the code that you're currently building. So it will also how to say, warn you or notify if you are not making a full build and so on. And you can of course do incremental builds after you have done a full build and so on. So you don't change anything of your source code, and you don't change anything in your build script. So it's just plug and play for most. And there is built-in compiler models for most embedded compilers, and there are also built-in library models for concurrency checkers for different RTOS and so on. Question, the difference between SonarQube and Codezoner. Well, to my understanding, or my feeling is that SonarQube is a tool that you can visualize the status of your builds or do smoke tests and so on. So you do or scanning a lot of code in SonarQube with different plugin for different language. While with Codezoner you will how to say, go deeper and build a model of your code, and also detect these concurrency issues and much more how to say, severe problems. So I think we made some comparison a couple of years ago where you found maybe 100 problems with SonarQube, and you found 1,000 problems with the Codezoner. So that is a magnitude difference between of what you find with Codezoner compared to SonarQube. One question: how does Codezoner integrate with special C compilers used for tiny embedded system, such as for PIC 8051 and so on? And as I mentioned, there is compiler models inside the tool, so you parse it just like your compiler will parse it. So there is a 30-40 different compiler models for embedded targets, and if it's not listed in or not supported, you can make your own compiler model. Another question: we are using Flexilink today. How does Codezoner compares when it comes to finding actual faults in the code? And I think it's the same here, that the Flexilink is the Linux version of PCLint, and I think you can in some extent find the same errors, but regarding concurrency and so on, Codesonar gives much more coverage of real severe errors. Flexilink, you need to run a couple of rounds to get many results, and it's also giving a lot of noise compared to Codezoner, where you can tune and also suppress warning quite easily. It will be much faster to work with Codezoner compared to PCLint or Flexilink. When you design a warning as security, is that cyber security or other security? Well, all the findings we do in source code, and that is most connected to common weakness enumerations, CWE, and it could be security problems in, how to say, I have a different difficulty to distinguish between security and cybersecurity, because this is the security related to coding problems, and maybe 7 out of 10 problems that in security is related to programming errors. So security significance in Codezoner is mapped to different security standards like CERT-C and other things. So when I spoke about a little bit about the other solution that Grammatech offer, Sentry, this is more a tool that scans your binary and identify which kind of components, especially open source components, that you have been using, and then map that to common vulnerability enumerations. So that's single V E, and that is found errors in cybersecurity, in National Vulnerability Database, and so on. So compared to Codezoner and Sentry, they can be used in a combination for cybersecurity. But in Codezoner, security is more related to coding errors. So I think that were all the questions that we have today, and we just passed our time for 5 minutes. So I think we will end up this session today, and if you have any more question, or do you want to try the tool or get a more deeper demo on your code, just get in contact with us at Know-How in Sweden, Denmark, or in Finland. So thank you very much for today, and thank you, Mikael.
Thank you.
Bye.
Bye-bye.